Alright, I've got a little math throwback for you. Think back to when we dealt with our congruence theorem. Side, 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 angle, and angle, side. Depending on the information given, you could determine whether or not two triangles are congruent. Well, we've actually got similar theorems that deal with similarity. These are going to be the angle-angle similarity. If two angles of any triangles are congruent, then those triangles are similar. Side-side-side similarity. If the side ratios of all three sides of two triangles are proportional, then those two triangles are similar. Lastly, we have side-angle-side similarity. If we have a given angle that is congruent, and then two different side ratios around the angle that are proportional, then the two triangles are similar. Let's see if we could use these theorems to determine whether or not two triangles are similar. Here we've got triangles with side lengths 2, 3, 4 and 4, 6, 8. Alright, we don't know angles, so this is probably going to be, if anything, the side-side-side theorem. Let's test it out by setting up some proportions. Well, I see 2 would correspond with 4. That'll give me 2 over 4. I see that 3 corresponds with 6. That'll be 3 over 6. And 4 corresponds with 8, which would be 4 over 8. The question is, are these equal to one another? Well, if I simplify these out, all of them would be equal to 1/2. So, that's exactly what we want to see. We can conclude these two triangles are similar based on side-side-side similarity. How about these two triangles? We've got angles of 30 and 102, and in this triangle we have angles of 48 and 102. Alright, well I see these 102s are congruent, but this 30 is not congruent to this 48. But we do have these missing angles that might give us some more information. So since I know that triangles add up to 180 degrees, I can fill these missing angles in. Doing that, I'm going to get angles of 48 and 30. Now, I see that 102 is congruent to 102, 48 is congruent to 48, and 30 is congruent to 30. So, these triangles must be similar. We can use our angle-angle similarity since we know that two of the angles are congruent. These two triangles both have a 90-degree angle. That's one angle congruent. And then we've got the sides on either end of that angle. So, well, this seems like it might match with side-angle-side similarity, but we need to check and make sure those side ratios are proportional. So let's go ahead and set those up. We'll have 10 over 5, and we need to see if that is going to be equal to 16 over 8, which both of those are equal to 2. 10 divided by 5 is 2, and 16 divided by 8 is 2. So, since we have one congruent angle and two proportional side ratios on either side, we have side-angle-side similarity. These triangles, we've got angles of 81, 60, and 40, 81. If we solve for these missing angles, we'll get 39 and 59. Looking at these angles, we do not have congruence. Therefore, these two triangles are not similar. Oh, I feel myself getting tired. Okay, hold on. Deep breath. Okay, stay focused. Here we've got two more triangles with side lengths 4, 5, 7, and 8, 12, 15. This might be side-side-side, but let's set up the proportions and see if it is. Setting up those side ratios, we have 4 over 8, 5 over 12, and 7 over 15. The question is, are these equal? Well, 4 over 8 is 1/2. 5 over 12 is not 1/2. So no, they are not equal. And no, these triangles are not similar because the side ratios are not proportional. Alright, last one of these. Here we've got two triangles. Whoopsie, wrong button. Here we've got two triangles, ACB, XZY. We see we've got one congruent angle. We see that we have two congruent sides. Alright. Now, what do you think? Raise your hand if you think these are similar. Raise your hand if you think they're not similar. If you did not raise your hand at all, you are right. We do not have enough information to tell. We've only got one congruent angle, so we can't do angle-angle. The congruent sides that we have are not positioned correctly around the angles, so we do not have side-angle-side, and we are missing the third side, so we can't do side-side-side. So sometimes you can't really determine it. You can just say we do not have enough information. Alright, before I sign off, I want to show you a couple things that will blow your mind. Alright, check this triangle out, or should I say these triangles. We've got a triangle here and a triangle here. Both of these triangles share this angle right on top. So that means you've automatically got one congruent angle. Next, we know that these two lines are parallel. That means their corresponding angles have to be congruent. So we could say that this angle is congruent to this angle, and this angle is congruent to this angle. Therefore, these two separate triangles here, one right here and one right here, are similar by angle-angle similarity. Now here we've got two triangles, one here, one here. First thing I notice is that we've got vertical angles. That means those are automatically congruent. Second, we've got parallel lines, which means these alternate interior angles have to be congruent as well. Therefore, since we've got all these congruent angles together, these two triangles are similar by, again, angle-angle similarity. Keep in mind that identifying similar triangles may just be the first step. There may be problems that require the application of knowledge in order to solve additional things, such as missing sides or missing angles. Remember that all similar polygons have congruent corresponding angles as well as proportional corresponding side ratios. Best blessings!